There's at least a couple of open seats here. Are we ready to go? Yes, hi. Everybody still awake after lunch? Yeah, well, I'm 50-50, awake and asleep. But today's topic, next generation problem solving team, for agile teams. And I would start to begin with a question. How many of you solve problems on a daily or weekly basis? Okay. How many of you think about yourselves as good problem solvers? Don't be shy. Come on, everybody thinks they're a good problem solver, right? A little bit about my background. I have about 15 years of experience in the IT industry. You could say I'm a jack of all trades. I've done many different jobs and roles in this industry, and a common theme has been agile and lean, and problem solving is especially a sort of favorite thing of mine, how to do it well. And my goal for this presentation is actually to challenge and change your perspective on what is good problem solving and how you should approach it. I work for a company called Nitor, and we have two business areas. We do software development, and then we do consulting on lean and agile and also continuous improvement. And there's one statistic that we're very proud of. For the last 3 years, we've had the best customer satisfaction results in Finland in the IT industry. My plan for today will probably change, and you can influence on what things we'll spend more time on. But my original plan is that we'll start out with sort of the state of the union for agile problem solving. So what's good, what sucks, and then we'll talk about lean problem solving, how that's different, what is Toyota Kata, and then we'll talk about the continuous innovation model. And within that, I'll first talk a little bit about Tree's theory of inventive problem solving, and then I'll talk about how to combine Tree's with Toyota Kata to form the continuous innovation model. And I'll be finishing with some practical tips on how you can get started in your own teams and your own work. So, first of all, a definition. What is problem solving? I would argue, and since this is my presentation, I'm defining that firefighting is not problem solving. A lot of the things that we think about as problem solving, that's just putting the same fires out over and over again. And what is actually problem solving is improving the performance of the system in a sustainable way. And by system, I don't mean just a technical system. I mean a social technical system that has people's roles, organizations, stories, culture, all that thing. So how can we improve the performance of that system in a sustainable way? And disclaimer, because I want to get out of here, I'm going to criticize some things about Agile. That doesn't mean that I don't think Agile is a good thing. I think it's absolutely wonderful, the things that we have achieved as a community. But still, we shouldn't get complacent. Just because something works, it doesn't mean that we should stop questioning if there's a better way of doing things. And I think definitely there is better ways of doing problem solving than many Agile teams are doing today. So, Agile problem solving. Now, this is not based on a scientific study. This is based on my observations on different Agile teams and how they approach problem solving. First, there's a lot of good things. Let's not forget that. First, the basic concept of having a cross-functional team solving problems, I think that's wonderful. And in many, not all, Agile teams have a safe-to-fail culture. That's also one of the building blocks of good problem solving. Many Agile teams have real ownership and craftsmanship, and you can't really do good problem solving unless you feel that you own the problems. And visualization is often used very effectively, and there's a bias for action, which is great. And you could say a lot of teams, not all, actually have a real culture of continuous improvement, and that's a positive thing. But I think there are a lot of challenges as well. And I'm going to go in depth in each of these statements and sort of try to open my thinking behind them. But first, I would argue that a lot of agile teams don't really understand what's the value the system they work in produces. And there's lack of system thinking. I know it's cool, we all talk about systems thinking, but if you really look down at the practical problem solving, you don't really see that much systems thinking. And then we rely too much on our intuition. And I'm not saying intuition is always bad, but I'm saying that it definitely has its downsides when it's used in problem solving. And then we're also sort of have this syndrome of not invented here to certain aspects of our work life. So, not understanding value. First of all, I think if I ask a lot of developers, they would say that working quality code is value. And I would argue it is not. There's a reason behind why that code is being developed. There's a business problem or a consumer problem that we're actually trying to solve. And in many cases, there actually can be solutions to those problems that don't require any working code. That's not always the case. You often need quality code. I'm not saying quality code is bad, but I'm not saying that the code is not the value. The value is solving the problem. And another thing I would like to say about understanding value is, as human beings, we have sort of these two levels. Like J.P. Morgan said, that we have two reasons for doing anything. We have the good reason and we have a real reason. And I think agile teams are usually quite good at understanding those good reasons, but not so good at understanding those real reasons, the intangibles behind decision making and what's valuable and what is not. And if we don't have a good understanding what actually value and especially intangible value looks like for different stakeholders, we can often make mistakes in classifying is something waste or is it valuable. For example, change management meetings. Who thinks change management provides value? Yeah, one brave soul. And I would argue that if you look at the tangible side, change management often doesn't provide value. There can be special cases. But if you look at like intangible values, like a feeling of security for certain stakeholders, it can actually provide value. It's very important to understand what value is, because if you understand what real value is, then you can find alternative ways of providing that value. Lack of systems thinking. Like I was saying, we talk the talk, system thinking is cool. Haven't seen much of it in practice. If we really look hard at the improvements that we're doing with our teams, can we honestly say that they're aimed at improving end-to-end flow for the whole process, or actually are they usually improvements that are aimed to make the life of the software development team more easy? And if we really don't understand how the system works, how can we improve it? It's just luck. We can try things, maybe they help, maybe they don't, but it's not a systematic way of succeeding. There are a lot of positive things related to system thinking and agile. I really like the DevOps movement, portfolio management, scale agile framework, but none of these things is a substitute for really first-hand understanding and knowledge. What is your system? How does it work? What is the value that it provides? And over-reliance on intuition. In a lot of retrospectives that I have facilitated and participated in, I have heard statements like, I feel like, yesterday I noticed this problem, I want to do something because some other team does it and it's cool. And there's nothing wrong with that by itself, but is it really a systematic way of understanding what are your bottlenecks? Are the things that you're trying out actually working? Are they doing real BDCI experimentation? Or are just doing, let's try this and then never come back to it again? And The reason why intuitive thinking is dangerous is cognitive biases. Psychologists know that there are over 50 bugs or cognitive biases in our brains. Things like the anchoring effect, confirmation bias. For example, car salesmen know very well what the anchoring effect is. If I say that this car, its value is 20,000 euros, you might disagree with me and say 18,000, but I already said the initial price, and if you didn't know that, you could have perhaps said like it's worth 3,000 euros for you. Or confirmation bias. Our brains are working very hard to hide things that don't fit into our worldview. So our brains are actively hiding information from us without us noticing it. And these are just scientific facts about being a human being. There's nothing we can really do about them. They exist whether we like it or not. But the way we work has a big effect on how big of a role those cognitive biases play. And not invented here. And what I mean is agile teams are really very good at adopting ideas that have a stamp on them that says agile. We're very, very good at noticing those things and trying them out. But if, for example, some way of documenting a feature has the reputation that it's a waterfall way of doing things, then many teams are hesitant of doing that, even though it could be a good solution in that context. And one thing that I think we could also do better at is finding inspiration from other domains. I don't think software development is that unique that we couldn't really learn from the experiences of other organizations in other domains. So, time to see if you're still awake. So, do you want to lynch me, or do you actually think that these observations have some merit according to your own observations? Let's test. Does everybody voting device work? Yeah? Almost 50%. Can we do something about these people voting devices? They're not working. Let's try again. Who is willing to admit that perhaps we're having some of these difficulties in agile teams when we're solving problems? Yeah. I have still hope of getting out of here alive. So, how many of you knows the concept of an S-curve? Yeah, most. So I won't go that deeply into it, but it's the idea that you can look at the life cycle of almost anything. It can be a technology, or it can be a paradigm or society. As an S-curve, it has infancy stages where most ideas die, and then some ideas survive, and they go through a quick growth phase until they actually reach the fundamental limits of that system. They just can't be improved within that paradigm anymore. And I would argue that the way many agile teams are solving problems is actually close to those fundamental limits, that we can't really do better problem solving by doing the same way that we're doing it right now. We need a new way of doing problem solving. And in this presentation, I'll talk about two other problem solving paradigms. I'm going to talk about lean problem solving and systematic innovation. So lean problem solving is a very wide topic in itself. And a lot of interesting things have been published in this area. But today I'm going to mainly focus on Toyota Kata. Again, let's calibrate our presentation. How many of you have heard about Toyota Kata or know the basics? So, okay, I can go perhaps a bit lighter over that. So, Toyota Kata, first of all, it's not just a problem-solving tool. It's based on a philosophy. It has two principles. First of all, everybody knows the second law of thermodynamics, that everything goes towards worse unless we're actively doing something to make it better. So we have to continuously improve everything or it gets worse. Nothing is stable. And the second aspect is a sort of softer side, the people development side. That people have a lot of potential, but for us to maximize our potential, to reach our potential, we need to actually systematically train ourselves to improve. And problem solving can be a good way of doing that, challenging ourselves to grow by using increasingly difficult problems. And Toyota Kata actually, I won't call them processes, but has two behavioral routines to achieve these goals. First of all, there's the improvement kata, which is a way of doing problem solving. It's a quite different way than many of us perhaps used to. And then there's the coaching kata. And the coaching kata is a way of teaching and mentoring and coaching the improvement kata. And they work together as a system. Today, I'm not going to talk about the coaching kata, but if you're really interested in this thing, you should really look that up as well. I'm going to focus more on the improvement kata side today. So, Japanese people are sort of funny and they have a lot of patience. So, they don't just start doing things when they see a problem. Crazy. They think about things. First of all, they start thinking about what's actually the long-term direction that they want to head. And they don't just invent, this is my long-term direction. They actually have a shared long-term direction which they want to go to. Then they still don't start doing things. Crazy people. They try to understand the current condition deeply. They try to understand as a system around the problem. How does that system work? And still no doing. Then they set a target condition about 1 month away. And then they start doing systematic experimentation from how to get from the current condition to the target condition. And they never stop. That's how they manage it. As long as you work, for example, a company like Toyota, you do this and you have somebody who coaches you to do it. You do it every single day, as long as you work. And it's interesting the effect that a shared vision has on problem solving. Because if we don't really have a shared vision between, for example, the software development team and the marketing team, we'll be pulling in different directions. But a shared vision actually, it allows us to improve the system, because then we can both solve problems towards a common goal to get the system working in one way. If you don't have that common goal, common vision, we'll actually most likely be just doing improvement that sort of help us and hurt the other team. I think I'll skip my PDCA because I heard that there's an excellent presentation on PDCA today. Everybody knows PDCA? No? Come on, guys. Then I have to talk. So PDCA, simple but very important. So when you do improvements, when you do problem solving, first always state what is your hypothesis, what is the expected outcome, and then design the simplest possible experiment to validate that hypothesis. Then you run your quick and light experiment, and then you honestly have to look in the mirror. Did that outcome actually match what you were expecting? Because this is a way of fighting, for example, our confirmation bias, that we like to see the world as we would like it to be. And if we write down the expected results beforehand, it forces us to be a bit more honest with ourselves. And then, of course, you have a new plan, or you sustain the results that you achieved if the outcome was what you were expecting. So overall, I would say that lean problem solving is it's really big step forward compared to what many agile teams are doing today, and it offers a good basic structure about thinking problem solving. And this is a topic that I've actually researched quite a lot. I haven't found a better one. There are a lot of okay ones, but this is pretty much as good as it gets as a basic structure for thinking about problem solving. Now, there are still some challenges even with lean problem solving. It doesn't help you understand intangible value. It has difficulties in understanding fuzzy problems, and it still doesn't help us utilize knowledge from other domains very effectively. So, systematic innovation. TRIS, Theory of Inventive Problem Solving. It's the scientific discipline of creating creative and innovative ideas. I don't know if you'll accept that, but as an engineer, that's a very appealing thought for me. And there's actually good data behind this, that being creative isn't something that happens to special people when they're in a dungeon or something like that, but it's something that you can actually approach in a very systematic and scientific way. There are certain things that you have to do in order to get creative or lateral ideas. It was born in Russia in 1946. It has its roots in traditional problem solving, traditional engineering problems, but since the 80s there has been a lot of research in applying it to business and IT problems as well. So, some of the TRIZ basics. First of all, there's nothing new under the sun. Somebody has always solved your problem before you. It doesn't mean that there's a solution to your specific context, but it means that there is a general solution to a similar kind of problem, and you just have to find it and think how you could apply that solution to your context. The other thing is we're sort of very easily get caught in psychological inertia, which stops us from seeing different type of ideas. And there are simple exercises that we can do to generate more creative ideas. So anyone can be creative with the right tools and right working methods. And TRIZ also offers quite interesting tools for analyzing and predicting the future evolutionary direction of a system. Understanding value. This is a very simple but very effective TRIZ tool. So what's the value provided by a car? Sort of the classical answer that many agile teams, of course this is easy, we know this isn't true for these sports car, the value isn't really the tangible value. It isn't traveling from A to B. It isn't transporting my family. It's part of it, but that's not the real value, right? What's the real value of a sports car? Yeah, exactly so. So we have to think about the J.P. Morgan quote, that people have two kind of reasons. The good reasons and the real reasons. And the good reasons are usually the tangible reasons. And many agile teams understand those very well. But what we don't understand so well in a systematic way is the intangible value. So what we can do in our own work is we can map out what is the value that we actually provide, also from an intangible perspective. And that will free us to find other ways of providing that same value. We don't have to get stuck in our old ways of working, but we actually understand what's the value of the way that we're doing things today from a holistic perspective. Another thing, it's about psychological inertia, it's about cognitive biases, is that most likely when we have a problem and we think about solutions, we only think about the here and now. So we look at how could we solve this problem right here. Perhaps if we're engineers, we also think about the subsystem. And the best problem solvers, they actually think about the past system, the past subsystem, and even few think about the future system and the future subsystem. But one thing that at least I haven't seen very much is problem solving on the supersystem level. And this is often non-technical solutions. These can be process solutions, business solutions, things like that. And an easy way to be a more creative problem solver is to systematically map out all these 9 windows when you have a problem and try to generate solutions to each one of those windows. No, I can send this. Yeah. Just email me and you can have the slide deck. I'm going to skip this one. How much time do we have left? 20 minutes. Including questions. That's great. Then I won't skip this. So, how many inventions have we made as a human race? Interesting question. No right or wrong answer. If you look at the patent database, you will find tens of millions of patents. But actually, those patents have been well researched and analyzed. And according to TRIZ, theory of inventive problem solving, a very rigorous scientific discipline, there are only 40 solutions. that we've only, as a human race, ever come up with 40 solutions. We're good at applying those 40 solutions in different contexts, and we can combine those 40 solutions to come up with even more creative problems. But there's only 40 solutions. Do you buy this? Good science. If somebody wants to debate this afterwards, I have good sources for this. And but it's sort of depressing on the other hand, but it's sort of liberating on the other hand. Because when you have a difficult problem, you can actually go through those 40 solutions. There are a lot of examples on how to apply these solutions to different types of contexts. So when you want to think of creative ideas, you can take the best ideas that we as a human race have had and apply them to your problem. Here's an example, blessing in disguise. This is often something when you're stressed out, you're not going to think about things in this way, right? If something is a problem, it's a problem, you just want to get rid of it. But many inventive solutions are actually based on a simple idea that you can take a negative effect on a system and then find a way to actually make it into a positive thing. For example, what would be a good example for this context? I really hate those lights. They're really pointed at my eyes, and I was having a discussion beforehand about is there anything that we can do about those lights. And I was sort of annoyed and stressed out by it. But then I had lunch and I decided that actually this is a good thing because then I'm not really stressed about my presentation, I'm just pissed off about the lights. So. But seriously, it's a quite easy thing that you can do to improve your problem-solving abilities, is to go through that list of 40 things. I'm not selling anything, it's freely available on the net. There's actually a link on the previous page if you want to look it up. And I promise you will get better ideas if you utilize these 40 solutions that we have come up with so far. There are a lot of other twist tools. I'm not going to read out these slides. I just put them here as a reference information. These are not all the twist tools. These are the tools that I have in my personal toolbox that I like to use. And now we get back to Toyota Kata. Because even though TRIZ is really, really cool, TRIZ doesn't actually have a good structure for problem solving. It has a collection of really good tools. And what Toyota Kata has is a really good structure for systematically thinking about problem solving. So you always start with the vision, understanding the long-term direction, you understand the current condition, you set the target condition, you experiment towards it. And for each of these phases, TRIZ offers actually really good tools that can help you do that in practice. So the continuous innovation model that I would like to propose for you is utilizing the best aspects of Toyota Kata. And when I'm saying that, I'm not just talking about the improvement kata, because even though we didn't really discuss it that much today, equally important in Toyota Kata is the coaching kata, because that's the way you support that you can create this culture that people actually have the energy and the support they need to do creative problem solving every day. And Toyota Kata offers an excellent structure. And TRIZ, on the other hand, really good, really creative, and yet surprisingly simple to use tools for both creating a vision. For example, I think that's one of the most difficult things in Toyota Kata, how to create a vision. TRIZ offers concrete tools for doing that in a way that are actually meaningful, because many vision statements are not, as I'm sure we all know. And TRIZ offers tools for understanding and analyzing our current condition as a system, and tools for ideas that can create experiments. And I'm not going to talk about it today because I'm sure you're all familiar, but lean startup techniques actually offer a good complement to both of these tools, because there's a lot of good ideas in the lean startup community on how to run quick PDCA experiments. So there's a lot of good research there that you can also utilize in combination with Toyota Kata and TRIZ. So If you're really interested in this topic, here's a few sources. First of all, I didn't go really deeply into Toyota Kata because it's a 45-minute presentation and I have a lot of things that I have to cover. But if you actually want to be a good problem solver, you should really understand Toyota Kata because it's a basic structure of how you should be thinking about problems. And Mike Rotter has written an excellent book about it, surprisingly called Toyota Kata, but it's a good book. It's definitely worth to read. And if you're interested in trees, first of all, I wouldn't say it's super quality, but it's good quality information freely available on the net. The best site is perhaps opensourcetrees.com. And then there's a couple of good books that I would like to recommend. There's Trees for Engineers by Karen Catt and Systematic Software Innovation by Darrell Mann. And if you're really interested in this idea of combining Toyota Kata with trees, which is sort of my invention, I published a research paper last fall about it in the Global Innovation Convention, which documents the current best practices of how to mix and match those techniques in different phases, and I can send that to you if you email me. And there's also a SlideShare presentation that I've published about that. But this is the study side, and then if you're awake, if you are taking notes, this is the one that I would be taking notes about. It doesn't have to be the contents of the slide, but what you should really be thinking about, if you find this interesting, is what will you do differently tomorrow? What will be the thing that you will start applying into practice? Because even though if you find this very interesting, you're curious about this, chances are you won't remember it a week from now. And the difference, if you really want to change something in your behavior, is to visualize what could be the first step that you could take. Some small step that you can do today or tomorrow. And I have a couple of suggestions for first steps. One is that if you already hadn't bought the Mike Rotter Toyota Kata Proof from Amazon, you can first watch a 1-hour video by Mike Rotter, which he explains the basics of Toyota Kata in a bit more in depth than we did in this presentation. And there are a lot of good trees tools, but I think perhaps the best one to begin with is the 9 Windows tools, because you can use it in almost any problem. And it's really simple to use, and yet you will get the benefits right away. Try it. I promise that you will generate ideas that you wouldn't have without it. And there's 2 blog posts that I have written about it. The first sort of covers the theory, and the second one shows a practical example of applying the 9 Windows method in practice. And it'll take 20 minutes for you to read those, and then take 40 minutes and apply it into some practical thing that you're working on right now. And in 1 hour, you will actually become a better problem solver. And one recommendation, even if you didn't really buy any of this tree stuff, if you're still doing retrospective with your Agile team, is do real PDCA experiments. It's not that difficult. You write down what your hypothesis is, you write down what your expected results are, you design the most simple experiment that you can come up with, and then you honestly look in the mirror that were the results the ones that you were expecting, and then you adjust your behavior based on that. Simple, very effective if you can make a habit out of it. So my summary would be, first of all, problem solving is really important. Problem solving is one of the key competencies that high-velocity organizations excel at. It's one of the 4 things that differentiate high-velocity organizations from regular organizations. If you want to look that up further, Stephen J. Spear has a lot of good research on that topic. Toyota Kata offers an excellent structure for problem solving. I haven't found a better one. I've been looking for a few years. And it's the best. Well, maybe somebody will come with a better one, but you can't really make a mistake by using Toyota Kata as your basic structure for problem solving. And TRIS offers some really interesting tools, simple tools that can help you in your lateral thinking in being more creative. And you don't have to be a TRIS master right away. You don't have to master 50 TRIS techniques. You can pick 1 or 2 techniques. You can pick the 9 windows technique. You can look over the 40 inventive principles when you have a difficult problem. And even that will already help you create better solution ideas. And if you really want to excel at continuous innovation, you actually need both. You need a good structure for problem solving, which is provided by Toyota Kata, but you also need tools that will help you overcome psychological inertia and come up with creative solutions. And please, I'm challenging you that if you disagree or agree, but please try something, because that's the only way that you can really change your behavior and improve. Make a small experiment, see if one of the quick steps that I recommended could actually help your team and you. Thank you. I would be, yeah. Any questions? I'd love to answer questions. Yeah.
Yeah, I'm curious about this when you position the different problem-solving sort of techniques, and you say traditional, then agile, and
Yeah. First traditional, First traditional problem solving, and now I'm using the term in a specific way. I'm using the way that most companies in practice solve problems, and they just sort of sit down and write out a few ideas and let's do that, and that really sucks. And agile problem solving, I think the key components of agile problem solving is the idea of trying things out and doing it as a team and do it on a regular basis. And those are good improvements compared to traditional problem solving in businesses, but there's a really lot more things that can be done. Lean problem solving, I would say the essence is that there's a system for doing it. You always think about what's perfect, what the vision, then you have a systems perspective of understanding the current condition, creating a goal that you're striving for. You're just not randomly improving. You're trying to reach some target condition that you think is good, and you utilize PDCA experiments. And if you think about systematic innovation, I think systematic innovation has all the good sides of lean problem solving, but in addition, tools that are aimed at creating creative solutions, fighting psychological inertia, utilizing the existing base of human knowledge. Yeah.
How do you see this kind of a solution-oriented problem solving, or we can also say second order problem solving, meaning that we can have a setting is that we have a vision, something we need what to do.
Yeah.
Instead of analyzing that where we are now and how could the vision look at that, what are the totally different ways to solve the problem, which sometimes leads to businesses that somebody innovates something that everything what we have done.
Yes, I think there's actually multiple. You should be doing that multiple levels. You just shouldn't do that on one level. You should do that when you have a vision towards achieving something, and then you usually have. I didn't talk about it today, but in Toyota Kata, you have a challenge that supports the vision, and you should definitely use. TRIS has a lot of good tools for it, different ways of achieving that challenge. But even though after you sort of make the decision, this is the big way we're going to approach this problem, you should still actually use in understanding the current condition. There are a lot of good tools that you can use to find creative other ways of reaching that, and you can even do it on the PDCA experimentation level. I'm sorry, did I understand your question? Yeah.
Can you give a simple example of those 9 windows? Really simple example. Super system and subsystem. Or do I just need to go and read the blog?
Yeah, well, you can read the blog, but I would say a simple solution, for example, the system level could be the software team. And the subsystem level could be different tools or systems that are used in the development process. And the super system level could be the whole company, the market, including the customers. And then you could sort of make, for example, strategical business decisions that we are going for a different market that could, for example, solve a problem. You could have a problem with performance, and solution could would be to find a customer who doesn't care about performance. I know that's a sort of made up example, but and then you think about time. What happens before? What happens? How do you come up with sort of the ideas what you should be doing, and what happens afterwards? What happens in the support levels? And also, in both time, you should think about the subsystem and the super systems. Still time for questions?
Yeah, we have time for 2 more questions now.
Yeah.
And if anybody would like to get rapid feedback in the
Yeah.
crowd here.
Yeah.
A couple of questions, yeah.
Okay, you heard the man. There's 2 more. We need 2 more questions. We won't get out before. No, they're just sleepy or shy.
Well, I would like to ask about like my problem or the problems we often get in retrospectives are such like not enough testing or the documentation wasn't up to date or something like that.
Yeah.
So how with the PDCA, was that right?
Yeah.
Yeah. So if you would try that, what kind of experiment would you try for this kind of common problem?
Really good question, but I'm going to dodge the question because I think that the first thing is that if you have problems with testing, for example, or documentation, you should be asking yourself why. You shouldn't be thinking about what the solution is. You should try to understand the current situation. Why are you having problems? Don't people know how to test well? Don't the tools support that? And you should get first-hand information from the people, but why? And when you have that why, you have your hypothesis, right? A hypothesis could be, for example, that actually our tools don't support proper testing in so-and-so scenario. And then you could create a PDC experiment based on that hypothesis, that okay, if this is true, then if we had, for example, this better kind of tool, then this problem would go away. And then you would design an experiment around that. But you don't design PDC experiments around sort of general problems. First you think about what is the sort of hypothesis why we have this problem, what's the reason, what's the why, and then you design a PDC experiment to test the why. So that was a political answer, sorry.
I think it's kind of you start with the Toyota Kata and then you
Yeah, because you shouldn't start, that's a sort of one key point of Toyota Kata, is you shouldn't jump into conclusions. If you have a badly defined problem, like our testing doesn't work, that's not a well-defined problem. And you shouldn't try to solve the problem. That's sort of the traditional approach. What you should be trying to do is gaining an understanding of why you have that problem. And then you can design experiments to validate if your assumptions on why you have that problem are true or not. That's sort of a systems thinking perspective of it.
I have more like another question. Because we do this what they call experimentation and innovation.
Yep.
In market research group in our university. There's like 2 kinds of experiments that we do. There's experiments that are aimed at finding out what the root cause is, or finding out what the problem is.
Yep.
Because there are often these cases where you don't actually know the real problem.
Yes.
You might know what is the goal state where you want to head, but you don't know what's standing in the way. So there are like you can design the experiments that are only aimed at finding that out, and then there are of course the other experiments which are solution experiments.
Yeah.
So more like a comment on the previous.
Yeah. I think the ideas exist in Toyota Kata. The language is a bit different. Sort of the understanding the current condition phase that often requires experimentation, and that's sort of the understanding phase, or figuring out why we have this issue. And then what's called in this model PDC experiments are the solution-oriented experiments. But the idea of really understanding what is the current condition is very strongly built into this model of problem solving.
And I think it's sometimes difficult for people to grasp that like finding out what the problem is requires this experiment. It's an active thing that it's not just observing or
Yeah.
not just asking people,
Yeah.
but actually doing something to change the current conditions in order to understand the problem.
Yeah. in the lean world, there's this word that is often used for that. It's called Gemba. What Gemba means is actual place where the work happens. So you can't understand the current condition by figuring it out inside your head. You actually have to observe and find out first-hand data, what is the current condition. Thank you. You've been a great audience.
Okay, so
No.
and before you leave, I would like you to give a quick return on time invested. So 45 minutes in this room, you have seen and heard a lot. What was your return on this time that you have invested here? 5 fingers meaning fantastic, best ever. 1 finger meaning totally that you won't get back next year. So hands up everyone, 1 to 5 fingers. Excellent. The lowest number I can see is a 3 and lots of 5s and 4s. Thank you very much.
Thank you.